see, we left off on page 155, and number 20 would be what we'd want to. I don't think we did 20, right? And a sphere. So what you want to do is go back and look at the surface area of a sphere. The formula there, the surface area of a sphere is 4 pi r squared. So is, it says find the surface area of the spheres having the following measurements. So the first one is pretty straightforward. And then that's 2.3 the quantity squared. And then you calculate that out. Then it's just a calculator problem. The next one, what you'd have to do is you're given the diameter, 6.7. So then you'd have to calculate the radius, which is half of the diameter. And then the surface area would be 4 pi, and then it's 6.7 over 2 the quantity squared. And then you put that in the calculator. And we're going to do the calculator part. The C part says they're giving you the circumference, which is 23 pi. Well, remember that the circumference is pi times the diameter, and then the radius is half the diameter. So you have to use this one to calculate the diameter. So your circumference would be 23, go 23 pi equals pi times the diameter. So the diameter would equal 23, and the radius would be 23 over 2. And then you do your surface area. 4 pi r squared, 23 over 2 quantity squared. And then that would give you the surface area. Okay. And then you just put it in the calculator and calculate it out. Says the radius of one sphere is 4 centimeters. The radius of the second sphere is 12 centimeters. How does the surface area of the two spheres compare? So we're using the surface area is 4 pi r squared. And so one surface area is 4 pi, and then its radius is 4 squared. And the second surface area is 4 pi 12 squared. So they compare. So if you want to have a not a fraction, and you want to compare them, then you'd go the surface area 2 divided by the surface area 1. So then you'd have 4 pi 12 squared over 4 pi 4 squared, which is going to be 12 squared over 4 squared. 12 is 3 times 4, right? Over 4 squared. So the 4 squareds would cancel and you'd have 3 squared, which is 9. The one is 9, the surface area is 9 times as great as the other. So that's how they compare. It says a rubber ball has a circumference of 6 pi meters. By how much should the circumference be increased if the surface area of the ball is to be tripled? Okay. There's several formulas. Surface area is 4 pi r squared. And the circumference is pi times the diameter, and then the radius is the diameter over 2. So those are the things that we're going to have to deal with. Okay. And it's going to want the surface area of the ball to be tripled. So what we have to do is we got to find out the surface area of the initial ball. And in order to do that, what we have is we have the circumference is 6 pi. So we got 6 pi equals pi times the diameter. So the diameter is equal to 6. And that means its radius is 6 over 2. So the surface area of this one is 4 pi 3 squared. And the surface area needs to be tripled. So the surface area 2 is going to be 4 pi r2 squared. We're going to have to calculate the radius of the tripled surface area and then go back and put that radius into that circumference formula. So surface area 2 is going to be 3 times the surface area 1. So we'll plug these two in. 4 pi r sub 2 squared has to be 3 times 4 pi 3 squared. So r2 squared is going to be 4 pi 3 squared over 4 pi. These go out. R2 squared is, this is a square, so this is 3 cubed. So R2 is the square root of 3 cubed. And that's 3 times the square root of 3. The surface, how much does the circumference have to be increased? So what we do is circumference 2 minus circumference 1 is what we're calculating. Circumference 2, the diameter 2 is 2 times 3 square root of 3. So it's that diameter 2 times pi, and then circumference 1 is 6 pi, right? Now this is actually 6 square root of 3. So this is 6 square root of 3 pi minus 6 pi. Okay. So So this is square root of 3 so we can factor out the 6 pi, can't we? Whatever that number comes out to be, that's going to be it, I think. They're saying round to the nearest tenth. I guess we can calculate that. Square root of 3 times 6 pi. So 13, and the round off to the nearest 10. So it'd be 13.8. It'd be 13.8 times as big. So 26. Now this thing, to see what they're talking about, find the surface area of a regular octahedron with each length 4 square root of 3 centimeters. If you look back on page 78, you'll see at the top of the page there an octahedron. So give it a shot at drawing that thing. isn't quite from perspective. And each one of those legs is 4 square root of 3. So this is 4 square root of 3. And each one of these are 4 square root of 3. And we want the surface area. Well, notice there's there's 4 on the top and 4 on the bottom. We just have to find the area that one of the triangles, and that's 8 times it, right? It's 8 times, because that base is not going to be part of it. So what we basically have to do, let's go in here. That green line is the height. And that perpendicular bisector of the vertex angle is the bisector of the base. So each one of those, these two sides, this side and this side, is 1/2 of 4 square root of 3.
So 2 square root of 3?
2 square root of 3 is going to be, and to find the height, we're going to use the formula, A squared plus B squared equals C squared on the right triangle. And so C is going to be 4 square root of 3, and we can calculate the B would be height. We'll call the B height. So height squared has to equal C squared minus A squared. So height is going to be the square root of C squared minus A squared, where C squared is going to be 4 square root of 3 squared minus, and then it's half of that. Each one of those is, like A is going to be 1/2 of 4 square root of 3. So that's 2 square root of 3. Squared. Okay, so this is going to be the square root of 16 times 3 minus 4 times 3, which is 12 times 3, right? 3 factored out, 16 times 4. And this is actually, this factors into 4 times 3 squared. So there's the 2 comes out, the 3 comes out, so that's 6. That green thing is 6. This is 6. So then our surface area, there's 8 triangles. Each triangle is 1/2. The base is 4 square root of 3, and the height is 6. See, this is 8, 1/2 base times height. So okay. this, you got 16 square root of 3 times 6. And that you just got to put in the calculator. Sixteen times 6, wasn't it? Oh crap. Hate it when I don't bring that out. Times 166.3. I don't know the units. What are the units? Centimeters. I haven't been too concerned about units, I guess. Okay. 28, the surface area. From here to here is 4.8 meters. You want to find the total surface area following solid. Okay, 28A. Surface area total. So it's the surface area of that circle, which is the base, right? And this plus the surface area of the half of the sphere. So the area base is pi r squared. So the surface area of the base is pi times 2.4 squared plus this formula is 4 pi r squared, but it's half of that, right? So it's going to be 2 pi, and then it's 2.4 squared. So there's a pi and a 2.4 squared that comes out of there. And then there's a 1 and a 2. So this is 3 pi 2.4 squared. I don't think I need that times in bracket. That's 2.4 work. So 54.3 should be it. And I guess if we're trying for units, next thing. It says, find the surface area of the following solid. This might be tougher to draw.
So what was the answer to that last one, 54.3?
Yeah.
Okay, thanks.
Part of this is going to be hidden, but I can't fit. Have to. Doesn't look really good. Okay, let's look at this. This is 6 inches. This thing is 2 inches between there. And these two are equal. This is equal to that. This is 5 inches. Okay. So that probably saying this is 6, this is 5, this is 5, and this is 5. Okay. So the total surface area, by the way, this is 28 is going to be the surface area of that half a cylinder, right? 1/2 cylinder plus surface area of a trapezoidal prism modified, because we're not going to have that top prism. So a cylinder we're doing 1/2 of that cylinder, and it's the surface area of the circle plus the surface area of the side. And then when we get done with that, I'll try to do that other thing. So it's 1/2, and that circle is pi r squared, so it's times 1 squared, right? Diameter is 2, radius is 1, plus circumference pi times the diameter times that height 5. Is that right? Plus something. 1/2 of pi plus 10 pi. So this is 11 over 2 pi plus. Now let's work on that other thing. It's the surface area of the hinge. And what we have to know is a height, right? We gotta know this. We gotta know this height. Well, in order to do that, we're going to have to know the length of this side, right? If we consider this, consider height here, then this distance is 2. And that leaves the remainder of 6, 4, split between these two. So this is 2 and this is 2, right? Do we have enough information? We need to know that height. Because it's 1/2 base 1 plus base 2 times the height.
Yeah, we just gotta calculate the height now.
Oh, it gives me the height 3. It gives me that height 3.
Hypotenuse.
It's 28b. You see, it's given me that height. It's saying this height is 3.
Means we have to calculate the hypotenuse.
So then, no, we have the height, so then the area, see, it's going to be the 2 times the surface area of the trapezoids. That total area is this. It's 2 times the surface area of the trapezoid plus the surface area of the sides. Now the surface area of the trapezoids are 1/2 base 1, 2 plus base 2, 6 times the height, which is given to me 3, right? And like you say, we need to calculate this side too, because we're going to have that to get the surface area of the sides. So this, I'll put it C. C squared equals A squared plus B squared. So C equals the square root of 2 squared plus 3 squared. 4 plus 9 square root of 13. So the surface area of we're going to calculate the surface area of these sides, this one and this one back here and this bottom. But it's not the perimeter, it's only this side summed with this one, summed with this one, times that height 5. So it's going to be, and each one of those C's are 6 square root of 13, so it's 2 times the square root of 13 plus 6 times the height of 5. So the height 5. Because there's only 3 sides. So we'll get this all together. 11 over 2 is pi. Because that's pi. It's 11 pi over 2. Plus, these 2's go out, and then it's 8 times 3 plus 2 square root of 13 plus 6 times 5. It's a lot to remember. Okay. Divided by 2. Plus, go back and look, 8 times 3, 8 times 3, plus, I think that's a bracket, isn't it? 2 square root of 13 plus 6 times 5. Bracket. 2 times square root of 13. What did I do? Delete. Okay. 2 times the square root of 13. Get out for me. That was plus 6? What was it?
Yeah, plus
Plus 6. Close the bracket times 5. I got it all right? Is that what you got? 107.3? And that's inches squared. Okay. 30. It says find the total surface area of hollowed out cylinder shown. Okay. fairly close looking. So from here to here, it's 10, right? And they show this inside. From here to here, it's 8. Showing from here to here, it's 18. Okay. Okay. So it's got to be the surface area, the total surface area has got to be the surface area of the outside cylinder plus the surface area of the inside cylinder plus 2 times the surface area of ends. And those ends is going to be the area of the larger circle minus the area of the inside circle. So I'm going to do the surface area of the outside is going to be the circumference, right? It's going to be the circumference times the height. And then circumference on the outside, circumference of the inside times the height plus 2 times surface area ends. So the circumference on the outside and the diameter is pi times the diameter. So it's pi times 10 times 18. Inside is pi times 8 times 18 and 2 times the surface area of the ends. Pi times 18 comes out of there. And then it's 10 plus 8, that's another 18, isn't it? Plus 2 times the surface area ends. So this is pi times 18 squared. And the surface area of the ends, 2 times, it's the area of the outside minus area of the inside circle. 18 squared to the outside is pi r squared, right? Times the radius is 5. The diameter is 10. Minus pi, the diameter is 8, so the radius is 4. Let me change this around. 18 squared pi plus 2, and pi comes out. 5 squared minus 4 squared. Plus 2 pi times 25 minus 60. What's that, 9?
Mm-hmm.
So that's another 18, right? 18 squared pi plus 18 pi 18 pi comes out times 18 plus 1. So that's 18 times 19 times pi. Whatever that comes out to be. That's it. We ended on solar here.
Are we having a quiz on Wednesday? You have enough material?
I think we'll skip the quiz.
All right.
This is 13.
I know you're disappointed.
What's that? Is that 18 plus 1?
What?
So that's the last one, 18 plus 1?
Yes.